Now we're going to be writing rules for these sequences. We're going to continue practicing that. As a reminder, here are the two rules, the top one for arithmetic sequences, the bottom one for geometric sequences. So now let's check and see if we have arithmetic or geometric, and if so, we'll figure out what either D or R would be. First, I'm going to check arithmetic. To get from -6 to -9, I would subtract 3. If I subtract 3, I get -12. If I subtract 3 from that, I get -15. If I subtract 3 from that, I get -18. So here it is arithmetic because we're subtracting the same thing every time. And that thing that we're subtracting is 3. So D is -3. Negative because we were subtracting. Now we need to just write our rule. If we were, say, looking for the 50th term. So for some value of n, a sub n, we know a sub 1 is -6 plus, then we have n minus 1 times the value of d that we just found. Now in number 2, we're going from 5 to 0.5 to 0.05 to 0.005. So this one looks a lot like we are dividing by something. So it's going to be geometric. What are we dividing by? So to get from 5 to 0.5, we would divide by 10, divide by 10 again, divide by 10 again. But since we're dividing, our value of r is going to be 1 over whatever we were dividing by, because this r should be something we're multiplying by. We would be multiplying by 1 over 10 each time. So then our formula for some value of n would be a sub n equals 5 times 1 over 10 to the power of n minus 1. Now let's find the 10th term for each one. So for the 10th term, that means n is equal to 10. I need a sub 10. That's equal to -6 plus 10 minus 1 is 9 times -3, which leaves us with -6 minus 27, which is -33. For the second one, for a sub 10, I have 5 times 1 over 10 to the power of 10 minus 1, which is 9. And then when I put that in my calculator, I get this thing that says 5 with a capital E and then -9. The way that that is read is just 5 times 10 to the -9. It's a really, really, really small number, so small that the calculator is not going to show it to me. Now in number 3, I can tell we're not adding or subtracting the same thing each time to get from one number to the next. We're also not multiplying or dividing. So here we're going to have to look for a pattern within our value of n itself. So for the first one, n is equal to 1. This is the second n, 3, 4, 5. So let's see how their placement in the sequence relates to the numbers. It looks like the numerator of each fraction is its placement, and then the denominator is just 1 plus that. So here we've got n over n plus 1. So if we were, say, looking for the 15th term, we would do 15 over 15 plus 1, so that number would be 15 over 16. In number 4, to get from 1 to 4, I would add 3, but to get from 4 to 9, I would add 5, so it's not arithmetic. If we were multiplying, to get from 1 to 4, I'd multiply times 4, but 4 times 4 is not 9, so that 9 is in the way. I see the 16, but it has to be directly after the 9. So we're going to do a similar idea as we did over here, because this one is not going to be explicit. So looking at the placement, we get up to 4 values of n. Based on its placement, I could do 1 times 1, or 2 times 2, 3 times 3, 4 times 4. So when I'm multiplying a number by itself, I'm squaring that number. So my pattern here is n squared. That means if I was looking for, say, the 10th term, I would take 10 squared, and that term would be 100. So now let's actually find that 10th term. So here, n is 10, so we need 10 squared, which is 100. That is the 10th term in this sequence. From number 3, if n was 10, we would have 10 over 10 plus 1, which is 11. That would be the 10th term here.